Hello. Today we're going to look at a dynamics problem. The problem we're looking at is an object is released from point A, so it's released, initial velocity is 0, and then it travels along this curved path. And the question is to compute Vs and As. In other words, question is to compute V, which is a velocity, and S is your curvilinear path, and As. All right? Or we can use V hat or A hat, it doesn't matter. There are different ways to describe velocity and acceleration. In other words, there are different coordinate systems you can use to describe velocity and acceleration. And you've got to choose the coordinate system which makes it easier to study the desired motion. In this case, this object is released along the circular path. So we're going to use a circular coordinate system. In circular coordinate system, we have a tangential unit vector and we have a normal unit vector. In that coordinate system, in general, velocity and acceleration are described in this way. So in this coordinate system, Vs is equal to S dot E hat t, and E hat t is the unit vector, is the unit tangential vector. So unit tangential vector. And AS has two components. It has a tangential component and it has a normal component. And where does it come from is, if to compute acceleration, you need to differentiate velocity with respect to time. If you differentiate equation 1 with respect to time, you've got S double dot ET which is the tangential acceleration, and then you have S dot E hat dot T, and you can find the derivation for the second term in any textbook, and second term results in S dot squared, or you can use V if that's easier to understand, V squared over rho E hat n. So the other way to describe this equation is V dot ET. So the magnitude of velocity, you differentiate the magnitude of velocity and find the tangential component of acceleration plus V squared over rho E hat n. This is called centripetal acceleration. Centripetal acceleration. And the whole theorem. And rho is radius of curvature of curved path. All right, let's call this equation 2. The desires are velocity and acceleration. What we are going to do is we're going to use the principle of conservation of energy to compute velocity first. So you know that as this object is released from this point and goes down to this point, the potential energy changes as much as mgh. The only component of potential energy you've got in this case is gravitational potential energy. And the change in gravitational potential energy is equal to the change in kinetic energy. So you've got, and because initially this object is released, then initial kinetic energy is 0. So you've got mgh equal to half mv squared, and v is your final velocity or the velocity at this point. This is what we're looking for, right? All right, if you solve, m cancels with m. If you solve this equation for v, you get v is equal to 2gh, which is the magnitude of velocity, right? h can be described in terms of s. So let's call this equation 3. H, or h of s, is simply r sine theta, and theta is this angle, right? Theta, which is also a function of s. Let's call this 4. And theta, you can, from basic geometry, you know that s is equal to r theta s. So theta s is s over r. This is 5. So 5 into 4 gives us h equal to r sine s over r. This is 6. And 6 equation, if you substitute equation 6 into equation 3, you get the magnitude of tangential velocity, or the magnitude of velocity. V is equal to 2g, and h is r sine s over r, right? So our velocity is equal to 2g r sine r over s over r e hat t, right? Okay. There's obviously no velocity along perpendicular normal direction. There is no motion in normal direction because the motion in normal direction is constrained by this path. So you only have motion along this direction. E hat t. There is no motion in this direction because the motion is constrained with your path. All right. So we've got the velocity 6, 7, yes. Now we are looking for acceleration. Acceleration, as we said, is v dot e hat t and v squared over rho e hat n. So you can, so because you've already computed v and you know that rho is equal to r, and it is a constant in this case, so you've already got centripetal component of acceleration. So what we are looking for is the tangential acceleration, right? Now, if you look at equations, let me see. If you look at equation 3 and you differentiate equation 3 with respect to time, so d dt gh is equal to d dt ddt half v squared. This gives us v dot. It is simple differential equation. So we have differentiated right hand side and then we differentiated our left hand side. We have set them equal to each other. So we are going to set them equal to each other. So v dot is equal to 2 cancels with 2. And we've got gh dot because h is the variable which varies with time, right? So from this you can say that v dot is equal to gh dot over v. V, you can redescribe V as your S dot is the same. So this was 7 and this is 8. So you can redescribe 8 in this form, GH dot over S dot. Because tangential velocity is essentially equal to S dot. The tangential velocity is essentially change in S with time. You measured S, the travel along this curved path with respect to initial point at any time, and then you can differentiate that and then compute tangential velocity. All right, so we've got V dot equal to GH dot over S dot. Now, if you look at equation 6, you can differentiate equation 6 with respect to time and compute H dot. So this is 9. Now differentiate equation 6 with respect to time. R is constant, so we have H dot on the left, we have R, and you differentiate sine, you get S dot over R cosine S over R. Again, simple differential equation. This gives us H dot equal to, R cancels with R, S dot cosine S over R. This is equation 10. So now that we have H dot, we can substitute 10 into 9 and compute V dot. So 10, substitute 10 into 9, we get V dot equal to G S dot cosine S over R over S dot, which gives us V dot equal to G S dot cancels with S dot cosine S over R. And this is equation 11. All right, now we have all the terms we need. If you look at the general form of acceleration in equation 2, we need to substitute 11 and we need to substitute 7 and 11 into 2 to compute acceleration. So we have 11 and 7 into 2. We have AS equal to G cosine S over R E hat T plus V squared 2G R sine S over R divided by rho, and rho set in this case is equal to R E hat N, which gives us AS equal to G cosine S E hat T plus R cancels with R. We have 2G sine S over R E hat N. Right? And this is what we're looking for. So we've got now, this is 12. So if you look at equations 7 and 12, you have velocity and acceleration in curvilinear coordinate system in terms of S. Hope you enjoyed this lesson, and thank you. See you next time.